Hello everyone. Today we will be starting with some more compounds of S block elements for group 1. Students are requested to drop down their names for attendance purpose. We will be starting in a while. Students are requested to drop down their names for attendance purpose. We will be starting in a while. Okay, so we'll start now. First we will start with microcosmic salts, right? Now what are microcosmic salt? They are found in urine and their formula is sodium, ammonium and then HPO4, where PO4 stands for phosphate ion, right? So these are left behind as residues when you extract urea from dried urine crystals. For example, let us say that you are having a urine sample, then you make dried urine crystals from that urine sample with the help of the alcohol, right? Now the residue that is left behind while you extract the urea from that dried urine crystals are known as what? Microcosmic salts. So they are basically found in urine. So its preparation, if you take, it is prepared by dissolving diphosphate and ammonium chloride in molecular proportions in hot water, followed by the process of crystallization, right? So if you mix disodium hydrogen phosphate and ammonium chloride in hot water and then process, you can obtain the microcosmic salt. Now its properties. Now amongst the properties we have to learn only one, that is the microcosmic bead test, right? So what is microcosmic bead test? Sodium metaphosphate is heated to give you NaPO3, that is orthophosphate, right? Now when you treat this orthophosphate with the colored salts of transition metals like copper 2 plus, Fe2 plus, Mn2 plus, nickel 2 plus, cobalt 2 plus, basically the D block elements except zinc, cadmium and mercury are known as what? Transition elements or transition metals. So if you treat NaPO3 with transition metals or the salt of transition metals, you will get a bead, a colored bead, right? So this is known as what? Microcosmic bead test. Individual ions, individual transition metals give individual colors. For example, let us say that copper is blue, so iron will be of different color, manganese will be of different color. So it can be used to identify the type of transition metal that is present in your salt. Okay. Now the next is the important compounds of potassium. We are done with the important compounds of sodium first and then we will deal with the important compounds for potassium. So first one is potassium hydroxide, which is also known as caustic potash, and the molecular formula is what? KOH, right? So its preparation is similar to that used for NaOH that we have done in the previous class only, right? So if you electrolyze the solution of KCl, the aqueous solution of KCl is electrolyzed to give you what? KOH. And it is also prepared by the action of soda lime on potassium carbonate. So what is soda lime? NaOH plus calcium oxide. When you treat it with potassium carbonate, What is potassium carbonate? K2CO3. Then also you will obtain what? Caustic potash or potassium hydroxide. So these are the two preparatory methods. One is the electrolysis of the aqueous solution of KCl, and the second one is the action of soda lime, that is a mixture of NaOH and calcium oxide on potassium carbonate. Now next one is the potassium cyanide, KCN. So its preparation is when you heat potassium ferrocyanide. This is a type of a coordination complex that you will learn in your 12th class chemistry. The complexes which are enclosed in square brackets, they are known as what? Coordination complexes, which we study under coordination chemistry, which is there in your 12th class. Okay, so this is treated with potassium. You will get what? Potassium cyanide plus iron. So this is the preparatory method for potassium cyanide. Now its use is basically it is used in electroplating. Why it is used in electroplating? Because it forms soluble complexes with gold and silver, right? So because of this property, it is forming soluble complexes with gold and silver. It is also used in extraction of these metals. That means potassium cyanide can be used for the extraction of gold and silver, and it is also used in electroplating. Now the next one is potassium chlorate, that you term it as KClO3. First we will learn its preparation methods. So preparation method is when you pass chlorine gas through potassium hydroxide, and the potassium hydroxide should be its solution, right? It should not be dilute, it should be concentrated. Now when you treat potassium hydroxide with chlorine gas, you will obtain what? KCl plus KClO3, which is potassium chlorate and water, right? Or you treat NaClO3 by KCl. So here what happens, that the exchange of ions take place. Na plus here, ClO3 negative here, K plus here, Cl negative here, right? So it is a kind of a double displacement reaction you can take, or you can write it as an ionic reaction basically, right? Where one cation is attracted by the other anion. So potassium will go with ClO3, it will form potassium chlorate, and Na will go with Cl and form what? NaCl. So this is another method of preparation of potassium chlorate. Now second one is that it is used as an oxidizing agent in the laboratory, and it is used for the preparation of oxygen also, right? So KClO3 is what? It is used as an oxidizing agent. That means it reduces itself and oxidizes the other species which is present against it. KNO3, if you remember, I think we have done in the previous class also, that it is known as the Indian saltpeter. It is known as the Indian saltpeter. Now you tell me, what is known as child saltpeter? Which compound is also known as child saltpeter? Anyone with the answer? Anyone with the answer? Which compound is known as child saltpeter? KNO3 is Indian saltpeter. Which one is known as child saltpeter? Yes, Dinesh, very good. NaNO3 is known as child saltpeter. Good. Sodium nitrate. Now, next we will learn about carbides. As the name suggests, it includes what? carbon, right? So if you treat lithium with carbon, it will form an ionic carbide of the type Li2C2, right? Here lithium is in +1 oxidation state, so you can also write it as C2 minus, okay, because 2 lithium will comprise of +2 charge. If you take the other metals, they do not react with carbon directly, but they do form similar carbides when they are treated with ethyne. The ethyne is also known as, basically the formal name is what? Acetylene. So this is ethyne, CH triple bond CH. It is also known as what? Acetylene, right? So sodium reacts with acetylene to form what? Sodium carbide, right? The reaction is in this way, will give you what? The 2 hydrogens will be replaced by sodium. So this will be minus plus, then this will again be minus, and this will be plus, right? Lithium can combine directly with carbon to form lithium carbide, whereas other metals, they do not directly combine with carbon, but they react with acetylene to produce their corresponding carbides. Now the next one is, these compounds contain C2 minus, I have already explained, and also they may contain C triple bond CH minus. Now if you replace one hydrogen, then this species is formed. If you replace the 2 hydrogens of acetylene, then this species is formed, right? So when these carbides react with water, they give ethyne again, or they give acetylene again. That is why they are known as what? Acetylides, because on hydrolysis they give acetylene. That is why these carbides are known as what? Acetylides. Next is complexes, crowns and crypts. So here first we will learn about complexes which are made by S block elements, group 1 especially. So here we are having what? Salicylic aldehyde, right? It forms complex with potassium, somewhat like this, that lone pair of oxygen donates to this. Here also lone pair present on oxygen donate to this. Now what happens, that more salicylic aldehyde molecules, then here the coordination number becomes 4. Then again what happens, that one more molecule of salicylic aldehyde coordinates with potassium, and such type of complexes are known as what? Salicylic aldehyde complexes, okay. Similarly, you are having what? Acetyl acetone complex. So what is acetyl acetone? It is CH3 C double bond O, CH2 C double bond O, CH3, right? So this is the ketone form of acetyl acetone, as we are having 2 keto groups here. So it is the keto form. In organic chemistry, you will learn about the keto and the enol form. Now what happens here is that if you are having, instead of double bond O, you are having what? Double bond OH, right? Here the carbon-carbon, actually what happens here is that this hydrogen is shifted to this oxygen. So this becomes what? Carbon, double bond carbon, and then it becomes here OH, right? So C double bond O hydrogen can also be written like this. So this is the keto form and this is the enol form. En for alkene and ol for alcohol, enol form, right? Now it coordinates with lithium in this way. Oxygen from here and here also from oxygen, then the coordination happens. Now another molecule of acetyl acetone in the enol form coordinates to it in this way, and this complex is known as what? Acetyl acetone complex, right? So potassium form complex with salicylic aldehyde and lithium forms complex with acetyl acetone. Now next one is the crown ether. Right? Now what are crown ether? They are made up of what? Carbon and oxygen. Here you can see that the orange one are carbon and the red ones are orange ones are oxygen and the red ones are carbon, right? So in between these crown ether, alkali metals, that is the group 1 metals, have a weak tendency to form complex with them, right? These crown ethers act as polydentate ligands. What is polydentate ligands? Basically, you will have this polydentate, monodentate and all stuff in your 12th class chemistry, but still I explain. See, if water is coordinating through oxygen, then this means what? That oxygen is giving electrons to, let us say, metal we are having here. So oxygen is delivering its electron to metal, right? Now let us say I am having such a molecule like NH2, CH2, CH2, NH2. Now what happens that there are two lone pairs here, right? So this molecule will donate its electron through this nitrogen also and through this nitrogen also. That means these type of molecules which are combining through only one atom, that are known as what? Unidentate or monodentate, and which are combining that which are basically using more than one atom for donation, that are known as what? Polydentate ligands, right? So crown ether act as a polydentate ligand here, and they coordinate with what? Alkali metals, right? So these are alkali metals. Rubidium you can see, right? It is coordinated through oxygen here. You can see that the oxygen of crown ether coordinates to rubidium. Okay, lone pair of oxygen coordinate to rubidium. So these complexes are also known as wrap around complexes. Crown ether we have discussed. Now we will discuss about cryptends in the next slide. So crown ether and cryptends, they are collectively known as what? Wrap around complexes. Basically there is a cavity here in which the alkali metals are fitted, right? So crown ether is what? Made up of oxygen and carbon. And now we will study about cryptends. So cryptend, they are macrocyclic molecules with nitrogen and oxygen. So see here that crown ether were made up of carbon and oxygen. Here you can see that the cryptends are made up of nitrogen and oxygen, right? So nitrogen and oxygen, they form complexes with what? Alkali metals. They form complexes with alkali metals, right? The name cryptate suggests that the metal is hidden in the structure, right? In this structure you can see that there is a cavity in which the alkali metal is fitted, but here you can see that the metal is hidden in the structure, therefore it is known as what? Cryptate. Now the naming of these structures you are having in your P block chapter. When you will study P block, then we will do these kind of structures. Okay. Now comes the biological importance of S block elements. The major importance is of sodium and potassium. You must have also studied, I guess, in your 10th class, like sodium potassium pump, right? So here you can see that it helps in neurotransmission. Just a second. Yeah, it helps in neurotransmission. So this is a neuron here, right? Now what happens? This is a dendrite and this is the axon. So what happens that the chemical signal or the nerve impulse moves from dendrite to axon. This is how the chemical signals are passed, or the information is passed to the neuron. This is known as what? Neural transmission, right? Now the cell membrane here, the neuromembrane here is basically having sodium potassium pump here, sodium potassium pump, in which there are sodium from inside are traveling to the outside and potassium from outside are traveling to the inside, right? So for each 3 sodium going out, 2 potassium will be coming in, 2 potassium will be coming inside. This is the work of sodium potassium pump, right? Now here the potential difference is maintained. You can remember that the outside of the cell there is positive charge more, and here in the inside there is less positive charge, or you can say that here it is the negative charge, right? Outside there is more positive and inside there is negative more. Now what happens that when the electrical signal is passed out, sodium, the channels are opened. So the sodium can also travel from outside to inside. You can see here when the signal passes, sodium can transfer from outside to inside. Previously it was going out. Now the channels are open when the nerve impulse is passing through. So sodium can also travel inside now. Now what happens? The polarity changes. First we were having positive outside and negative inside, right? Now we will be having what? Negative outside, because sodium will be traveling what? Outside. So the excess positive charge, if you will see, before the impulse, positive was outside and negative was inside, and after the impulse, what will happen? That positive will be inside and negative will be outside. So this creates a potential difference, on the basis of which you can say that the nerve impulse is traveling from the dendrite to the axon. Is it clear? Is the working clear, or shall I explain it once again? See, what happens here is, you just need to have an idea of this. I'll explain it once again. Let us say that you are having a neurocell here, right? Somewhat like this. These are the dendrites through which the electrical signal comes to the neuron, right? So from here the electrical signal comes, moves through the axon, and then it is passed through this terminal which is connected to the dendrite of another neuron, right? Now what happens here is, this membrane, you can see the cell membrane here, consists of sodium potassium pump, in which what happens is that 3 sodium goes out and 2 potassium comes in. 3 sodium goes out and 2 potassium comes in, right? Because there is more charge, more positive charge outside the cell, therefore the outside of the cell is positively charged and the inside of the cell is negatively charged, because you can see that more sodium are going out rather than that of the potassium that are coming in. So there will be more positive charge outwards and the negative charge inwards, right? Now what happens when the electrical signal passes through this? When the electrical signal is passing through this, what happens is that certain channels are opened through which sodium can come inside also, right? This happens only when the signal is passing through. So when the signal is passing through, the channels which allow sodium to go inside now are opened up. Now what will happen, that the polarity will change. First it was positive outside and negative inside. Now it will become what? Positive, negative outside. So because of this change in polarity, neural transmission is possible. Is it clear now? Previously, when the impulse was not passing out, the sodium were not able to move inside. Only when the electrical signal passes through this neuron, then only the channels which allow the sodium to come in are opened up, and therefore now the polarity changes. And due to this potential difference, neural transmission is taking place. Now, what is the importance of sodium and potassium? So, if you take a typically 70 kg man, he contains 90 gram of sodium and 170 gram of potassium. And if you compare the quantity of iron and copper, only 5 gram is iron and 0.06 gram is copper. Now, some more things about sodium and potassium. So, sodium is found primarily on the outside of the cell. They are located in blood plasma, right? And these ions participate in the transmission of nerve signals, as we have already done this, okay? And it is also used in the transport of sugar and amino acid into the cells. Now potassium, if you take, potassium are most abundant within the cell fluids. That means within the cell potassium ion concentration is more, as we have seen in the neural transmission already, and it activates many enzymes. For example, it participates in oxidation of glucose to produce ATP. And what is ATP responsible for? Energy generation. Energy generation. And it is also responsible for the transmission of nerve signals along with the sodium ions that we have seen in the previous slide only. Okay. Now next, this is the sodium potassium pump. Already discussed that 3 sodium goes outside and 2 potassium comes in, and ATP is converted into ADP. That means energy is released here, right? Now in blood plasma, what happens is that sodium is present 143 millimole per liter, whereas potassium is present at the level of 5 millimole per liter only. Right, while inside red blood cells, if you will see that these concentration changes to, now from 143 sodium becomes 10 millimole per liter and potassium comes to 105 millimole per liter. This suggests what? That sodium is present in greater concentration outside the cell, and potassium is present in greater concentration inside the cell. And because of these ionic gradients, what is ionic gradients? Because there is a difference in concentration of sodium inside and outside and potassium inside and outside. This energy basically, or this factor, drives the sodium potassium pump, right, which we have already studied. It is responsible for neural transmission also, and it also converts ATP to ADP, releasing energy. These all things you will learn in bio in detail. Okay, you can just have an idea of this here. Now next is practice questions. We will practice some questions based upon the previous concepts. The first question says that choose the correct order of lattice enthalpy in the following. This we have already done. Which will have a greater lattice enthalpy? Anyone with the answer? We have discussed already. Amongst the fluoride, if you compare, lithium will have the highest enthalpy and cesium will have the lowest enthalpy. While amongst fluoride and chlorides, if you will compare, which will have a greater enthalpy? We have done already. Anyone with the answer? See, fluorides have a greater lattice enthalpy. Here you can see that lithium fluoride will be having the highest, then sodium fluoride. So fluoride's enthalpy will be greater than that of chloride. So lithium fluoride and sodium fluoride, now if we will consider, see, first point is what? That fluorides will have a greater lattice enthalpy than chlorides, right? Second one, if you compare amongst lithium fluoride and sodium fluoride, lithium fluoride will have a greater lattice enthalpy than that of sodium fluoride. Why? Because with fluorides, what happens is that lattice enthalpy decreases down the group. But if you will compare the chlorides now, NaCl will have a greater lattice enthalpy than that of LiCl, because in chlorides the lattice enthalpy increases down the group. For fluorides it decreases down the group, and for chloride, bromide and iodide it increases down the group. So the answer is C. Now this you should be able to do. Identify the correct order. Identify the correct order. Anyone with the answer? See, here if you will consider the percent ionic character. Percent ionic character is what we can compare with Fajan's rule. Fajan's rule says that smaller the cation, larger the anion, greater is the ionic character, greater is the covalent character, right? So here you can see, because cesium is a bigger cation, that means the ionic character will be more. So as the size of cation is increasing, the covalent character is also increasing. Therefore, yeah, just a second, sorry, as the size is increasing, size of the cation is increasing, the ionic character is increasing. Size of the cation is increasing, covalent character will decrease, or we can say that ionic character will increase. Because according to Fajan's rule, smaller the cation, larger the anion, greater is the covalent character. That means bigger the cation, greater is the ionic character, right? So here you can see that cesium 1 will have a greater percentage ionic character. Okay. Now next, if you see, now tell me this question. A plus water gives NaOH, and when you heat A at 400 degrees Celsius, it gives B, and when you treat B with water, it gives NaOH plus oxygen. And B is used for oxygenating in submarines. What are A and B? What are A and B? A plus water gives NaOH, and when you heat A, okay, Sarayu is saying D. Okay, let's look at the reactions. See, if you treat Na2O with water, it will give you what? NaOH. And now if you will heat Na2O at 400 degrees Celsius, it will give you what? Sodium peroxide, which on treatment with water will give you what? NaOH plus O2. Right? So Na2O2 is used for oxygenating in submarines, and we have already learned that Na2O plus water will give you what? NaOH. Now the next question is, electrolysis of KH produces hydrogen. I'll give you a hint for this question. It is K plus and H minus, right? So from H minus you have to produce H2. So this will be done on which electrode? Cathode or anode? H minus is converting into H2. That means H minus is losing electron. H minus is losing electron, and loss of electron takes place at which electrode? Loss of electron takes place at which electrode? Loss of electron is what? Oxidation. So oxidation takes place at which electrode? Anode or cathode? I have given you the hint for this question. Anyone with the answer? Loss of electron takes place on which electrode? Cathode or anode? Oxidation takes place at which electrode? Okay, Dinesh is saying anode. Good. Yes, so the oxidation or the loss of electron will take place at the anode. So electrolysis of KH to produce hydrogen gas will be at what? Anode. Okay, so this way you have to judge. If it would have asked that K plus or KH is being converted into potassium here. So this means that K plus is gaining an electron to give potassium, right? Now what is happening here? Gain of electron is happening here. That means reduction is happening, and reduction takes place at what? Cathode. So the answer would have been cathode. Always remember that on anode oxidation will take place. That means loss of electron will take place, and at cathode reduction will take place. That means gain of electron will take place. Okay. Now next is, which of the following statements is correct? Which of the following statements is correct? No, if you talk about NaHCO3 and KHCO3, these are the structures. See, this is a chain-like type of structure, and here you can see it is a kind of dimer here, right? So, solid NaHCO3 and solid KHCO3, they are having different structures. Okay. So, here the correct one is, because see, lithium carbonate is soluble in water, that is incorrect. Lithium carbonate is insoluble in water, right? However, the B option, that is lithium carbonate decomposes to give lithium oxide and CO2, is correct, because lithium carbonate decomposes or basically is heated to form lithium oxide, which is more stable. It is more stable. And one thing you need to remember about the CO2 is that it turns lime water milky. It turns lime water milky. This property of CO2 you need to remember. Now, this question can have one or more answers correct. It is a multiple choice question. When KO2 reacts with water, the products are KO2 plus H2O. Direct question. What are the products? What are the products when KO2 reacts with water? So here if you see, KO2 reacts with water to give you what? KOH plus H2O2 plus O2. So the answers will be what? KOH, H2O2 and O2. This is a direct question. If you remember the equation, then you can answer this question. Now next one is KO3 or Na2O2 are used in submarines or space capsules because Na2O2 I have just discussed now in the first question. In the first question, we have discussed about Na2O2. I hope it can give you an idea. KO3 or Na2O2 is used in submarines or space capsules because. Anyone with the answer? This can also have one or more answer as correct. Why they are used in submarines or space capsules? Hint I have already given, that we have discussed in the first question, where it was written that B compound is used in submarines as a oxygenating agent. So here if you see KO3 and Na2O2, that is sodium peroxide, they absorb CO2 and they release oxygen. So basically their work is to provide oxygen in submarines or space capsules. Now next question is, again you can have multiple correct answers. Na2O can be prepared by Na2O can be prepared by. Yes, Dinesh, you are correct with your answer. A is also correct, that they absorb CO2 also. Okay. Na2O can be prepared by which reaction? So if you see here, Na plus NaNO3 will also give you Na2O. Na plus NaNO2 will also yield you Na2O, and Na2O2 plus Na will also give you Na2O. So through these three reactions B, C and D, you can obtain Na2O. These are the preparatory reactions for Na2O. Okay. So these equations that I am mentioning here are very much important from your examination point of view. Revise these equations. Okay. Now next one you should be able to answer. Which of the following properties are in the increasing order from top to bottom for metal ions in group 1? Which of the following properties increases down the group? Increase down the group. Ionic radius, hydrated radius, ionic mobility or hydration number. You can have more than one answers. Anyone? This you should be able to answer. Which property increases down the group? So if you see here, ionic radius, if you calculate, they increase down the group. This property increases down the group. Hydrated radius, because we know that smaller the cation, greater is the hydration, right? So hydrated radius decreases down the group. That means in aqueous form, lithium plus will have a more size than that of sodium, then potassium, and then rubidium and cesium. Right? So these are in the aqueous form, that means in the hydrated form. If you treat ionic mobility, see, because hydration of lithium plus is more, so its size is greater now. So in aqueous form, what happens is that cesium plus, if you will take, it have a greater ionic mobility because it is having a less size in aqueous medium, therefore it is lighter, so it will be able to move freely, right? So its ionic mobility will be more as compared to that of lithium, sodium, potassium, rubidium and cesium. So ionic mobility increases down the group, right? We talk about ionic mobility in terms of aqueous only, right? In terms of aqueous solution only, we talk about ionic mobility. So answer is A and C. Hydration number also, if you will see, that it decreases down the group. It decreases down the group as the extent of hydration also decreases down the group, right? So the answer is A and C. Now this is the last question. This is a multiple matching. That means A can have two options that are matching. B can have two options or C can have two options, or either they can have one option also. This is Na2CO3, sorry, sodium carbonate. So Na2CO3, we already know that it is what? Also known as washing soda. Well, sodium bicarbonate, NaHCO3 is known as what? Baking soda. Right? So Na2CO3 is washing soda and it is also soluble in water. So A is matching with R and T. Now calcium chloride, it is used as a desiccating agent. That means basically it is used to remove moisture. Right? Desiccating agent means that it is used in a desiccator in which the moisture is removed. So calcium chloride is used as a desiccating agent and also it is soluble in water. So B becomes P and T. Now calcium sulfate anhydride, we already know that it is called dead burnt. It is called what? Dead burnt. And NaCl, if you will see, it is used for preparing freezing mixture. It is used for preparing freezing mixture and also it is soluble in water, as we know that table salt is already soluble in water. Okay. So this is how you can get questions from S block. Practice more and more questions that will help you to retain the facts. Okay. So that's all for today. Happy learning to all.